Let's discuss Advent of Code 2022, day 25. We will only discuss part 1 of this problem. Uh, we are basically given a list of inputs. These are numbers which are in SNAFU format, and we have to convert these numbers into decimal format and sum this up and then convert it back to the SNAFU format, and that is the answer to the puzzle. You can see input is like this. So some interesting facts about this SNAFU format is like the numbers are in the powers of 5 instead of 10, and this 5 is very important here. And the other thing is like the digits are only 2, 1, 0, minus 1, which is represented by this minus sign, and minus 2, which is represented by this equal to sign. Here's an example of some decimal number in their corresponding SNAFU format. So if we discuss the solution here, so basically we are given this 4 digits 0, 1, 2, minus and double minus, which is 0, 1, 2. This is minus 1 and this is minus 2, and if you notice, like, these are also 5 digits and the power is also 5. So that so it kind of gives a hint like each number can be represented uh, in some way of shape or form using this 5. So okay, let's assume with an example, if we take any number and take its remainder with 5, we will get we can get 0 if it is a multiple of 5, 1, 2, 3, or 4. So 0 basically means it is 5x, and 5x plus 0, and this means 5x plus 1, this is 5x plus 2, this is 5x plus 3, and this one is 5x plus 4. So, and if you further think like this 5x plus 3, if I take this one 5x plus 3, this can also be written as 5 next multiple x plus 1 minus 2, and this minus 2 is something which is given to us. So this can also be written as 5x plus 1 minus 2, and this can be written as 5x plus minus 1. So, and let us also like see this with some examples. If we write number from 0 to 10, 4, 5, 6, 7, 9, and 10. Here multiple of 5's are 0, 5, and 10. So this is starting of 5 into 0. This is 5 into 0 plus 1, 5 into 0 plus 2. And this is 5 into 0 plus 3. But as we do not have plus 3, we have minus 2. So we can say 5 into x plus 1, which is basically 5 into 1 minus 2. And this is 5 into 1 minus 1. Again, this is 5 plus 1, 5 plus 2. This is 5 plus 3, but we can also write it as 10 minus 2 and 10 minus 1. So every multiple of 5 can have these 5 numbers around this. And so let's assume we have a number like 10. We have to find this SNAFU format. So what basic steps we will follow is we will first take the remainder by 5, which is 10 remainder 5. This comes out to be 0. So the first digit is 0 here. We write it as 0. Now we divide it by 5. It comes out to be 0, or it comes out to be 2. Now we have to find what is the representation for 2. That we already know, it is 2. So 2, 0 is the representation for 10. We can also double check it from here. For 10 the representation is 20. And how to convert this back into normal decimal format? That is pretty straightforward. The 0 place is 1, so 0 into 5 to the power 0 plus 2 into 5 to the power 1. So this comes out to be 10 plus 0, which is 10. Let us take one more example with a more trickier one, which is like 28. So 28, like just by calculation we know 28 is like 30 minus 2. But like if we follow only our steps here, so if we take remainder by 5, this comes out to be 3. 25 plus 3. So the first digit is 3. Representation for 3 is, if you remember it, 3 is minus 2, which is a double equal to. So we write a double equal to here, and we do now 28 is close to 30. So we will take 30 divided by 5 here, because I told you, like if the remainder is 3, we will do an x plus 1, x plus 1, 5 into x plus 1, and so this is 30 by 5, this comes out to be 6. Now we have to find what is the representation for 6. Now 6, again remainder 5 comes out to be 1, so we'll write 1 here, and if we divide this by 5, this is uh, close to 5, so 5 by 5 is also 1, and representation for 1 is again 1, so this ends here, and so this comes out to be 1 1 and equal to, and if we try to convert it, this comes out to be 25 plus 5 minus 2, so this is 28. So I think if you take 2-3 examples here, it would be more clear, and I'll show you the code now to explain it better. So this is basic code template that I've been following for these puzzles. I've done some of them. You can find it in the GitHub repo. Just reading this file and passing it to the calculate score, the entire input. So first of all, we are uh, reading all these numbers one by one, converting them into the decimal format, and taking their sum. So if we see this encode function, what it is doing, so let's say this number is 2112, right? So we have this values map which tells us that what is the value for this 2 1 and minus and equal to. As you can see, for 0 it is 0, for minus 1 it is minus 1, for equal to it is minus 2. So we will take this, we will get the value from this map, multiply it by the power of 5 based on the digits. Like for 1 equal to 2, this is the I is equal to 0 here, so the value comes out to be 1, and length is 3. 3 minus 1 is 2, so this is 25. First this is 25, uh, minus 2 into 5, which is 10, comes out to 15, plus 1 16. So this is how we calculate the decimal value of one uh, number. And then when we do the sum, we have to decode it also to the uh, to their format. And how we are doing decoding is we are using recursion here. So if the number is 0, we'll return an empty string. This is the base case to complete recursion, and we will calculate remainder like we showed in the diagram. remainder with 5. If the remainder is 0, the first digit is 0. And for the for the remainder number, as it is completely divisible by 5, we will decode we will call this decoder again for number by 5. If the remainder is 1, then that means this last digit is 1, and it is closer to 5. So if you see this diagram here, so this is like the sixth case. The remainder is 1 and it is closer to 5. So we will do a minus 1 and divide by 5. Minus 1 divided by 5, we will decode that, and the last digit would be 1. For remainder 2, the last digit is 2. We will do minus 2 by 5. This is similar to a case of 7, right? And now if the remainder is 3, remainder 3 is a case like 8. So the last digit would be minus 2. So we have appended an equal to here, and we have to call decade for number plus 2, because this is 5 plus 3, and we do not have a representation for plus 3, but we have it for minus 2. So this will be 10 minus 2. So minus 2 is equal to, we have added that, and we are doing here 8 plus 2 divided by 5. And for last cases, remainder is 4, and we are it is like 10 minus 1. So minus 1 is a normal minus sign, and we are doing number plus 1 by 5. So this will recursively decode that, uh, convert our decimal number to their format. This will give us the final answer. Um, yeah, that's it. That is only for part 1 of this problem. I hope it is clear, and the code can be found in the repo. If you have any doubts, let me know in the comments. And if you try this for 2-3 numbers, I think it would be, the pattern would be clear then. I was not doing this advent of code regularly, so I cannot open further parts. So this is only the solution for part 1. Hope you are able to get it. Thanks.